Hi, I'm Martin, and welcome to Groundhog Graphics. This is the first video in a series of programming in C, Chapter 1. So, welcome to Chapter 1. Alright, now you see I got code blocks already open, and I am going to go and create a new project. From the project menu right here, option, we will select console application, click go. And we're going to be making a C file because this is a C tutorial series, not C++. Next, project title. It's going to be Chapter 1, CH1, Example 1, EX1. So let's see what we have here. This right here is your folder where you can choose where to create your project. As you can see here, I have, actually you can't see here, hold on. I go up one level, you see here code blocks. I go in there, this is where I'm going to save my projects. I go select folder. And project file name, it's added the extension CBP for code blocks project. And the resulting file name is the entire path and chapter 1, example 1. So okay, everything looks good there. Let's go ahead and click next. Oh yeah, I already tried this once, but yeah, I'm going to go ahead and overwrite it. Okay, so we have the GNU GCC compiler. What the compiler is the compiler is a program that translates our C programs, our C source files, into machine language. And the computer, only thing the computer understands is machine language. So the computer can't actually understand C. And if we were programming in Java, it can't understand Java. It doesn't understand C++. It only understands numbers. And it has a language of numbers. And the compiler's job is to convert our higher level language into the machine language the computer can understand. And assuming we don't have any errors when it's compiling, that's exactly what it'll do. Now below here we have some tick boxes. Create a debug configuration and create a release configuration. Now, creating a debug configuration is great. When we're working on the program, we want to create debug information, create a symbol table, and it helps us find bugs and get rid of them. Now, when all the bugs are through and we've finished our product, that's when we would produce the release version. The release version would be the version that you would put on sale at a store, the final release. So that looks all good. Leave it all checked. We'll click finish. Profile file already exists. You won't get this, but yeah, I'm going to go ahead and overwrite it. Warning, are you sure? Yes, I'm sure I want to overwrite it. Yep. Okay, now on the left we have our workspace, and this has a list of all of our files that belong to our projects. A lot of times in a larger C program, you're going to have maybe multiple files. You could have a lot of files, and this would keep them organized over here to the left. Now, in this particular project, we are going to have one file. And let's go ahead and expand source. And now we see we have a main.c. Now, when we created the project, CodeBlocks IDE was kind enough to create this file for us. Let's double click it. And it was also kind enough to write a program for us. But we don't need their program. So I'm going to select it and delete it, because we're going to write our own program. And I'm going to go ahead and delete the main.c. I'm going to remove it at least from our project. Yes, I want to remove it. Okay, now we removed it from the project, but it's still on the hard drive. we'll take care of that in just a second. But now we have no files in our project. We want to create a file. And this is important for you to know because later on you're going to want to create files and add them to your project. So let's go up here to the left, go up to the File menu, and we go to New, and then we go and we select File. Now we have some options. So from the Files row right here on the left, we have C, C++ header, C, C++ source. We will have need for header files eventually, but right now we are going to need a C source file. So we'll click that, go to Go. And yes, it's already set for a C file. Next. Okay, file name with full path. So let's go to this little box to the right and click it and choose a path. This will be a good path. Now here is that main.c still lingering. I right click it, I'm deleting it, I'm putting in our name is going to be same as the project name, chapter 1 example 1.c. Okay, now we'll go ahead and save that. And we would like, yes, we would like to have a debug and a release version. So check those two tick boxes. And we do want to add the files to the active project, so click Finish. Okay, now it's already opened up Chapter 1, Example 1. If we go over here and expand sources, we can see it here in our management window. So let's go ahead and begin writing a program. We're going to start off with an include statement. And it starts with a pound sign. Include, then a less than symbol. And we're going to include the standard input-output header file, which will provide extra functions for us to use. It's a very, very common, almost guaranteed that you'll see this include file in most C programs. But anyway, it is standard input-output is abbreviated as stdin.h. Then we have a greater than symbol to close it. And this is actually not even this is not even part of the C language technically. This is a preprocessor command that you will find in every C compiler you try to use, but it is not technically, it is not C. It doesn't even require the same formatting as C, and you'll see why here in a moment. Now we'll go down here and we're going to create the main function. In C, everything is functions, and the beginning or where the program begins execution is at the main function. I'm going to type in int main open and close parentheses and then open and close curly braces, which you will find on the right side of the P on the keyboard, and just use Shift. So now I'm going to bring our curly braces down. There, now that the colors on it, you can see the curly braces. So what we have here is we've defined the main function. To the left, you're going to see the int. int stands for integer, which really means whole number, a number that has no fraction. And then main is the name. It is a required name for your C program to start with the main function. Other functions now can be named whatever we want to name them. The open and close parentheses, we could put some variables in there, and when the system, like Windows, DOS, calls our program, it could pass us some information which would be command line parameters. So if somebody typed the name of our program and then they typed some other letters or whatever symbols after it, the operating system could send those symbols to our program so that we could actually parse it and take it apart and figure out what it is the user sent. Other than that, there's nothing you're going to send to the main function. So in this case, we're not dealing with command line, so I have nothing in the parentheses. I hope that's not too confusing, but don't worry. We will be going over this stuff a lot in this series. Now, the open and close curly braces. Everything that defines our function, defines how it works, is in between those curly braces. So when we define this main function, everything this main function will do, it will be defined from the beginning curly brace to the last curly brace, and that's it. Now, I am going to create a variable. It's going to be a variable. It's going to be It's going to be a variable that stores one single letter of the alphabet, one character. And I'm going to C-H-A-R. Char is a data type in C. So because I want to store a letter in a variable, I need to tell C what kind of variable it is. And the kind of variable will be char. Now, let's see here, char, and I'm going to name the variable var, short for variable. It could be anything we want, but right now it's var. And then we're going to, now we don't have to do this. We can put a semicolon right after it, and that will declare a variable in C. And that's good enough. But you can optionally, and it is also good practice, to put an equal sign and initialize it to something. In this case, something is going to be the letter A, capital A. And I'm going to close this line with a semicolon. In C, almost all lines are going to end with a semicolon. What it tells the compiler when it's processing our source code is it tells us, or tells it, that this is the end of the line. If we don't have the semicolon, the compiler will get confused and it will throw an error. Now, I believe I've made a mistake. On the A, I put quotation marks. That's not right. What we need is a single quotation mark or apostrophe on each side of the character. Only with a single character do we use this apostrophe, okay? Every other time we deal with letters and stuff like this, if we do it more than one, we will use quotation marks. But a single letter, use the apostrophe on both sides. If you don't, you get an error. Now, enter. I'm going to make a little space, keep our code clean. Notice the tab, the indent I did. It is common practice in C to indent almost like paragraphs of your code. However, it is not required. You don't have to have any indentation in C. So just so you know, it's just for formatting and to make it look nice. Our next line is going to be something that we can use to output to the screen. And how we can output to the screen is because we included stdio.h, Standard Input Output Library. And it has a function called printf, standing for print function. And it has open and close parentheses, all functions do. Inside these parentheses, it's going to have an open and close quotation. And inside the quotations, I am going to write var equals %C. Now you're probably going, wait a minute, what is this? Why do you write this? Okay, printf allows you to do certain tasks with it, and it will allow you to print what you write between the quotation marks verbatim to the screen, but it has certain special characters. And a special character would be the percent sign. And this percent sign tells it that, okay, I want to do something special in this place. And what we're doing special in this place is we're going to print the value of our character variable. Maybe I forgot to mention that the variable is used to store data. There are all kinds of data types. So C comes with a basic set of data types, and eventually we will be creating our own more complex data types. So anyway, a variable is used to store data, and that is the only way that we can process the data in our program or pass data back and forth in our program. It always has to be through a variable. Variables are key. And if we want to do mathematical functions, we do those on variables as well. So now, var equals %c. %c means a character variable. Now, next I'm going to write a backslash. This is like some text processing going on right here. \n is the same as a carriage return on a typewriter. And what it does is there's a visible cursor on the screen. And when we print our line, at the end of it, if we don't put the \n, it will leave that invisible cursor right there. If we go to print something else after that, it will print directly at where that invisible cursor is at the end of our line. Well, I don't want that because this line is already complete. So I'm going to put a carriage return at the end with the \n, which stands for new line character. Now, after the quotation marks, the end quotation mark, this is where we get to put our variables in. And we have to separate by a comma. All parameters, when you send to a function, will be separated by commas. So, in this case, var, and that's our variable. Now, notice when I did the printf, in the quotation marks, I put a capital V for var. Well, you know, proper English, you capitalize, right? Don't do that when you're actually writing your variable, because C is case sensitive. If I change the V to a capital V in var, well, I have now an entirely new variable. And in the printf statement, if I did that, well, we never defined a capital V var, so we would have an error. Okay, well, I think we're ready to execute our program. Cross our fingers, hope we don't have any bugs. How we can do it, we go up here to the build menu. And in build, we have the option build and run. What this does is it tells the compiler to go ahead and start processing our source file. If it works out right and it has no errors, then it will execute our program. So let's go ahead and execute. Okay, there it is, var equals A. You can see A was substituted where we put the %c. So %c, and then you see also the variable var, how it holds data, and the data that we put in, of course, is A. And now, it's nice that in code blocks, when we run this, it automatically like holds the screen out for us and lets us see it. Some compilers don't do that. So I'm going to show you a little trick if you're using a different compiler. Come on. Okay. We're going to add a line after the printf. And what we're going to put in is getc, which stands for get character. And what that's going to do is it's going to pause the program and require us to hit a key before it will exit. That way, if you're using a compiler that when you execute the program and it just flashes, or maybe it goes so fast you don't even see it and it returns you right back to the editor, this will fix it for you. So get C, open close parentheses, semicolon. Now, between the parentheses on this one, we're actually going to put something in. We're going to put the standard input. which is like a file handle. Um, stdin. Oh, outside. Come on. stdin. There. So what stdin does is it was actually defined in our include up at the top of the program. And getc was also declared in that include for our standard input output library. So standard in right now is set for the keyboard. It could be changed, but it will default to the keyboard for stdin. That is a input channel. So there's also an std out, but we don't need that right now. So let's go ahead and execute the program, and I'll show you that now we have to hit a key before we can before the program actually stops executing. Let's see here. F9. Okay. Now you see there's nothing printed after. And oh, there's this little turquoise cursor looking thing. That's my cursor on my computer. I guess Windows has decided to add that to our program, but you're not going to see that. So anyway, now I'm going to hit a key, and bam. Now we exited, execution stopped. So now we can hit a key again, and we go back to the editor. Okay, so now I want to demonstrate, or at least show how %C works a little bit more. Because it works basically as it's a substitution, what do we call it? Placement substitution. It substitutes that spot where %C is for the value that's in var. Now, if I wanted to, and I wanted to print more variables, I could put space %C space %C, and now I would need 2 more variables. Well, I'll just reuse var. So, comma space var, comma space var. Space isn't required, but put it in there so it's easier to read. So now let's go ahead and press F9 and see what the program does. Oh, now var equals AAA, AAA. Cool. And it's got spaces in between. Now, let's go ahead and go back to editor. Okay, well, I changed microphones, so I probably sound a little different at this point. I want to show you also how to leave comments in your C code. So I'm going to put the cursor up here at the top where we have our include. I'm going to drop it down a couple of lines. And in C, we have a /* to open up where we would leave a comment. This is a comment. And then we have to reverse it by */ to close the ending of the comment. Now that works in all versions of C. Newer versions of C, you can use 2 / and put this is a comment 2. And you see you don't require any closing slashes for that. Now, if I want to come down here like to include, and I were to hit tab and put 2 / this is include, we can comment like that, which is kind of neat. And basically the difference here is this is a comment line. 2 / is a comment line, and it has to be all in one line. The other one is known as a comment block, and let me show you another example of a comment block. ***, tab. This is a comment block, and then we close it. */, and now that is a comment block. Now, a lot of times, even when you're debugging code, let's say we didn't want to use our printf, we could do 2 /
and make it where it's not part of the program anymore. So sometimes when you're debugging, and we'll figure this out more later on, but you can comment out code that's either troublesome or code that may be interfering with you finding a particular bug. Uh, and then another way we can do it is to, of course, make it a comment block. Oop, what happened? Oh, those color things mess me up. And then an asterisk, and we close the comment block. So what this has done, which is not really very visible. Oh, it's not really, because see, up here this is a comment block, really didn't change color, but all this code right here is now gone. Okay, it's not going to be, the compiler when processing the file will ignore it because it thinks it's a comment, and I can prove this by executing the code with F9. Oh, no, F9. There we go. And you can see the program now does nothing at all. So then we hit a key, and that's because we commented out the only part of our code that actually did something. Oh, too many. There we go. Let's see. Okay. So now we know what a comment is: comment line and comment block. Experimentation with the \n. Let's do that. So now you see how we've printed with %c. We have the placeholder %c that prints all the values of our variables over here to the right. Okay, well, \n. Let's see if what we can do with that. We can do \n here, and we could do a \n, and we could do another \n, and what do you think that's going to do? Well, let's find out. Let's execute it. Yep, there it is. I wish that turquoise thing would go away, but underneath the turquoise cursor that Windows has so graciously added for me, there is an A. So it did print var equals AAA, each on their own separate lines, just like a typewriter with a carriage return. So that's a new line character. And we will exit and go back to editor. Now that we've done that, I'm going to show you what happens when we don't when we take a semicolon out. There we go. Now we have a missing semicolon, and we can see the error that it's going to happen. F9. Oh, wrong. F9. And we have an error here at the bottom. Error expected comma or semicolon before printf. So you see it got confused, and it thought, and it thinks the line is even below where the error is. It thinks the error is on the printf because the end of line terminator semicolon is missing, so it doesn't know where the line ends. It thinks the line just continues down. So put our semicolon back, and I think that does it for our first chapter, and we covered quite a bit, and it's been fun. So hey, thank you for watching, and I will see you in chapter 2, programming in C. Catch you later.